All right, everybody. So, Starbucks drinks are predictably more expensive for larger sizes. Okay, that makes sense. Now, I don't know if the author actually gathered this data from an actual source or if he made it up a little bit or whatever. But he's basically saying that since it's in chapter one, the data pretty much forms a straight line, as you can see there. Um, so it's a pretty straight line. It's not perfectly straight. I mean, the line doesn't go through, well, any of the points perfectly well, but it's an approximately linear or straight line pattern. And that's, well, not always the case. The more you buy, usually the less you pay per ounce. And so oftentimes the points might have a pattern that's a bit more like this. And so instead of a straight line pattern, you have something like that. We'll take a look at that later on in the course. All right, so once again, we've got X values here, Y values there, just like everywhere else in the book and everywhere else in algebra courses. So find slopes, or I'm sorry, round slopes and y-intercepts of 3 decimal places. All right, got it, whatever. Okay, so they've got all the data here. So we know the exact data. They've plotted the data for us. Ooh, that's nice. And they've come up with the trend line. So, hey, one more could a guy ask for. So part A, find the equation for the trend line using the regression feature of your graphing calculator. Okay, now it's time to get serious. Okay, whoops. Let me click on that. All righty. So get rid of that thing. Okay, so let me pause this. Okay, so the first thing we've got to do is because it does say use your graphing calculator to find the equation of the trend line. One way to do that is to pick a couple of points and then just do it by hand. Another way, which we're going to do a lot of, and plus it says use the regression feature on your calculator, is we're going to use the regression feature, which is slick as snot. So we're going to go stat and then option that first option. So enter or 1. And if you've got any data there, like I do from some previous problem, I'm going to go up to the name of the list so I can get rid of all the data in the list at one time. And I'm not going to hit delete. I'm going to hit clear and then enter. There's other ways to clear it out, but this works fine. So go to the name of the list and hit clear enter. All right. So in list 1, L1, I'm going to put my X values. And again, we're doing this so that we can do regression in the calculator, whether it's chapter 1, linear regression, or chapter 2, quadratic, or exponential, or logarithmic, or whatever. You're going to go through the same process. So it's really nice. So get this down really good for chapter 1, and it will make the other chapters easier. Let's see, 5.65. Is that right? I think so. Okay, so I've got all the data in there. And what was the question again? Find the equation. Oh, find the equation. Okay, I dig it. All right. You know what? Let me just make it big. Cool. All right. So that's how you enter the data in. Now to use that data to get the regression line or trend line to tell the calculator to do it, I now will go back to stat, but instead of hitting the enter key, I'm going to hit the right arrow and go to calc. And this is where all the regression lives. Option 4, that's linear regression. That's chapter 1. Option 5, quadratic regression. That's chapter 2. Later on, we'll need logarithmic regression. Option 9. We'll need exponential regression and power regression, but they all work about the same way. But chapter 1 is linear regression. Okay, so we'll pick that and make sure it says L1 here and L2 here, because that's where I put my X values in L1, I put my Y values in L2. That's probably what it says on your calculator. But if it doesn't, the way to fix it would be okay. So then to get the L1 there, notice right above the number 1 button, it says L1 in blue. So I go blue, L1. And then that gives me that. And then L2, L3, and so on. Okay. So then I'm going to go down to calculate, and boom, it just did the equation for me. All right. Now, I don't have the R values. We're not really going to need them, I don't think, until chapter 6, the last chapter. If you have the R values, great. If you don't sweat it. Okay. Now, what? Now, when I in the homework and on tests, when it says give me the equation, I don't want you to write it out like this. I want you to write it out like an equation and say, all right, so up here, the first thing you see is the template. Okay, so it's y equals ax plus b, where a is 0.144, because they said go 3 decimal places. And after a, I'm going to do x. After x, I'll do a plus sign. After the plus sign, I'll do b, which is 2.825. Okay, so this is an acceptable answer for an equation. This is not. This is, good, but we can certainly do better. And so, this is what I'm going to accept. All right. So that is going to be our equation. All right. So let's see, part B, use your regression equation. That's what we just got, what I just wrote down. To estimate the price Starbucks could charge for a 28-ounce latte. Okay. So they give me a numerical information, 28 ounces. And then I have to ask myself, is that an X value or a Y value? Well, it's the units associated with 28 are ounces. Okay, ounces, that's X. If it were dollars, that'd be Y. But that's an X number. So in order to use this equation, I'm going to plug 28 in for X, ounces. So I say, all right, so Y equals 0.14. And again, you're going to do a lot of the same stuff. Do a lot of the same stuff in all the other chapters. Plus 2.825. Okay. And now if we take a look at this, it's like, okay, well, a 28 ouncer, it should be more than $5.65. Okay. Because a 20 ouncer is that. All right. So, and it looks like we're going up by about, I don't know, 45 cents or so every 4 ounces. So if we're going to go up 8 ounces, I would expect to go up 45 cents twice, approximately. So, a little over 650. Anyway, let's actually figure that out. So I'm going to go 0.144 times 28 ounces plus a base cost of $2.825. Whoops, that's a 5. Okay. So $6.86. That would be it for part B. $6.86. That would be our estimate. Does that seem reasonable? Yeah. I figured, $6.50, maybe a little more, kind of winging it. So, yeah, so that sounds good. Part C, there's 4 parts to this. Okay, use your regression equation again to estimate the size a drink should be. Oh, this time we want to figure out size. We want to solve for X, which means they're going to give us a Y. They're going to give us a dollar amount. Estimate the size a drink would be if Starbucks wants to charge $6.25, rounded to the nearest ounce. Okay. Now, before we go on to that, I just remembered something I wanted to mention just real quick. We could have used the graph to get, a decent estimate. Well, it would have been difficult. Yeah, because 28 ounces, that's not shown. It only goes up. Let's see, this is right here at the end is 25 ounces. So, oh, well. Okay. But they say, hey, how about a $6.25 latte? Well, 6.25 is that's a Y value because it's money. And so I'm going to go on the Y axis here. Well, here's $6, here's $6.50, so 6.25 is going to be right in the middle. and I'm trying to keep that line. And so where does that line I just drew, where does it intersect the trend line? Looks like right about there at just, well, I sloped it a little, about 24 ounces, maybe a hair less. That would be my estimate. Okay, going off the graph. Now, that's not going to give me a perfectly accurate answer, but it should give me a pretty good estimate. And so being able to do that with your graph is a great way to just quickly and easily check your work. Okay, all righty. So what do we do? Well, I erase a little. What I do. Okay, so I'm getting a little space here. I don't know what that's doing. Okay. So this time they say 625 is a dollar amount, a Y value. So I'm going to plug 625. I should do that probably a little higher. I'm going to plug that in for Y, not for X. Okay. On part B, they gave me an X number, an ounce number. On part C, they're giving me a dollar amount, a Y number. So I plug it in for Y. If I plug the 625 in for X, and that says 6.25 ounces, that's what I'm telling the equation. And that's clearly not what I want. Okay. All righty. So now we have this equation. We want to solve for X. Hallelujah. So I'm going to take away 2.825 from both sides. Okay. And then, you know what? I'm just going to do that on my little handheld here instead of flipping back and forth. 825. Okay. So that's going to give me, did I click on the, there it is. Okay. 3.425 on the left equals 0.144x. All right, and now I'm ready to divide by 0.144. Okay, 0.144. And I get, let's see, it says, I'll just go one decimal point because this is not a slope or a y-intercept. I get x equals 23.8. And what are the units for x? X is ounces. Okay, so remember, you got to include your units or you're wrong. Okay, 23.8 ounces. Hey, that's pretty darn close to our estimate. I said, hey, 24 ounces, maybe just a little less. I feel very comfortable with that answer because it's consistent with my estimate from the graph. Again, they didn't ask me to do the estimate on the graph, but it helps me to know if I'm right or wrong. Plus, it helps me to understand what's going on a little better, and it's good practice for reading that. All right, part D. State the slope and y-intercept and explain their meaning and context. Okie dokie. All right. So the slope, or let's talk about the y-intercept. Let me change colors. Fun. Okay, so the y-intercept, that is when y is all by itself, that's the number that is not multiplied by x. Okay, that's the y-intercept. We typically refer to that as b, although that's not especially important. Okay. So the y-intercept, that is where your line is going to hit the y-axis. Okay. Clearly, I didn't draw that perfectly well, or the author didn't, whatever. But that's where it's going to hit the y-axis. Now, so in other words, it's going to hit the y-axis at 0, 2.825. Okay. And so, now the fact that this clearly is not going to hit at 2.825, which is like down here somewhere, if you bring that thing down, that kind of makes me suspicious that maybe my equation is wrong. Except, you know, that answer to C was really close to what was, you know, to what I expected. So I'm not sure. You know, it'd be a good idea for me to go back and double check. I typed everything into my calculator correctly. Okay. Anyway, so this is going to be the y-intercept. Y-intercepts are on the y-axis where x is 0 every time, and then this guy is just the y-coordinate. So now remember, x stands for ounces in this problem. Y stands for dollars. So for your explanation of what this means, which is very important, you would say something like, if you bought a latte or whatever we're talking about here, if you bought a latte for that was 0 ounces, it would cost you $2.83 or $2.82. I know that would be weird. It's like, well, why would you buy a 0 ounce latte? Why would you want one, and why would you pay for it? Well, or you could say, the base price, I guess, is about $2.83, and then you start getting charged per ounce after that. But you need to explain what it means. Again, the X value, that is, in this problem, ounces, and the Y value is dollars. Okay, so it's $0, or at 0 ounces, you're paying $2.83. Okay, so we got that. Now, what about the slope? The slope is the number that is multiplied by X. Okay. Now, we've already learned in this course that slope is found by doing the difference of the Y values divided by the difference of the X value. So in other words, the units of slope are the Y units divided by the X units, which in this case is going to be dollars over ounces. When you go to the grocery store, you typically refer to this or read this as dollars per ounce, because the slash, the division bar, always means per. So dollars per ounce. So that's what this guy here is telling you. It says that the slope is telling us, oh, okay, so we're being charged $0.144 per ounce, or in other words, about 14 cents an ounce, or well, about 14.5 cents per ounce is what they're charging approximately. So that's what you would want to say, something like Starbucks is charging $0.144 for every ounce of latte concoction, or something like that. Anyway, that is the idea, and everything in this problem is important for this section and gets used a lot throughout the remainder of this course. So make sure you learn it up real good.